What you are seeing on the screen is a prosthetic product being manipulated as a template part via the product template author. This tool allows non-technical people to manipulate parametric CAD through its prescribed values to generate a new configuration on the fly. At Designfusion, we help O&P customers simplify their workflow through software, services, and 3D printed technologies. A video presentation on YouTube by O&P Designer caught my attention the other day. It was a very well presented video showing the viewer how to manipulate parametric CAD for prosthetic adjustments. Two things I noted. While O&P Designer's method did solve a problem, I realized how cumbersome some other CAD tools are. I suggest watching the video at least the first 11 minutes, and there's 9 minutes of setting up sketches and expressions to accomplish the task. Then coming back here and seeing how we accomplish that task in NX. And number 2, O&P Designer mentions using multiple software to accomplish a task, such as a mesher tool for converting the facet scans into usable surface data. And that is something I've seen with various companies. They jump in and out of various CAD products, maybe specific O&P tools, and then external tools such as Blender to accomplish their tasks. So in this video, we will show you the simple steps to set up a parametric assembly ready for templating, and also highlight some of the integrated tools so that you don't have to leave NX. Here we have a facet body imported from scan data. We want to constrain the leg axis to the mounting axis, but not directly. We want to have some parameters to control the position and angles of the connection. This way we can make easy adjustments for fitment purposes. As we are in the assembly structure, we can turn off the leg while we work in the context of the assembly. If you watch the O&P Designer video, there is a long section of setting up expressions to position the initial offset location. With NX, we have an offset coordinate system that combines all of that into one feature. Out of all the coordinate definition types, we choose offset CSys and choose the existing CSys as the reference. Position and angle will be directly related to the original coordinate system. Here's where we can establish offsets in X, Y, and Z. We can fill in static X, Y, and Z values. We can also do arithmetic type operators in this dialog box. One benefit of NX is that it allows us to generate expressions on the fly. So in the value entry, I can type an expression name like coronal offset and then equate it to a value. We can do the same with sagittal offset and the Z offset. In the back end, NX is creating these new expressions with the proper data type. We could also immediately add rotations about the reference system axes to simulate the coronal and sagittal angles. And for small angles, this would be fine, and we would be finished the setup here. But without going into a deep dive of tip and rotations or two tips or compound angle theory, just know that this method is not how the angles were being applied in the O&P Designer video for two reasons. One, these rotations are based on the original coordinate system axes, so once we rotate the one direction, the next rotation is not about the new system. It still references the old one as the orthogonal rotations about the reference axes. And number two, in the O&P video, the coronal angle is done about the y-axis first, but this feature applies the rotations in order seen here, X, Y, and Z. So we would get a different result than what we saw in the O&P setup. So for now, we'll leave these rotations alone and set them back to 0, but also ensure that associativity is turned on so that any adjustments in the original reference coordinate system are reflected in our offset system. When we move to our part navigator, we can see that the user expressions were created on the fly and they're available here for adjustment. Now to match the O&P setup, we will create an angular setup using another definition type. Here we choose the Tate-Bryant angles. This lets you choose the rotation sequence, and the rotations are done about each new axis position in the previous sequence. So this will emulate the multi-step sketching that O&P Designer had to go through to achieve the result he wanted. So to do a step-for-step match, we will choose the Y, X, Z Tate-Bryant angle. And so the first rotation will be the coronal angle. Second rotation will be the sagittal angle. And the third rotation will be the in-toe, out-toe angle. With those set up, I'm going to reference that from the offset position coordinate system we created previously. both for the orientation and the origin point. And here we see the new angle expressions NX created in the backend added to the user expressions. We turn off the intermediate coordinate system and review our final coordinate system that now holds XY position and Y XZ rotation information. Now I'll turn off the mount hardware so we can just see the coordinate systems, and we can adjust the angles via the expressions. And in this case, we're setting them all back to 0. NX was fine with 0 offsets and 0 angles. It doesn't flip the orientations like you saw in the sample video from O&P Designer. This means templates are robust and dependable. And as a feature note, selecting any features will show you the adjusted values in the detail pane. So I'll add a value back to the coronal angle, and then the second rotation is the sagittal angle. And we'll rotate that about the new axis. And the third rotation is about the z-axis, in this case with the angle measured on the xy plane of that coordinate system. Okay, so now the good stuff. Via the Assemblies ribbon, we access the Align constraint, and my filter is set to coordinate systems. So constraining these two components is just a matter of selecting the From and To coordinate systems, and using Apply brings those coordinates together. We can now test our setup by adjusting the assembly expressions. And as we see, it's moving the component position as expected. And so here is the beauty of integrated workflow in NX. We don't need to exit the program and open up a facet body meshing tool or use an external mesher product. We just change to sub-D modeling inside NX via the Realize Shape task environment. So we open a new tabbed window so we can just look at our leg model. We click the Realize Shape icon to get into the tool, and we choose Cage from Facet Body. We select the facet body, and we can set our subdivision size, but in this case I'll just leave the default for this demonstration. It generates a set of tangent faces stored in one subdivision body. If we hide the facet body, we can review the body created. So we do have ways to check the sub-D surfaces against the facet model and check for deviations, but we can do that a quick way as well, just a visual check by offsetting a surface a small amount and seeing what bleeds through. And so we can use a small value such as 0.15 millimeters and review the result. We see the body is mostly outside of the facet, so we can drop that down a bit and recheck at 0.125 and see we have a very close match to the scan data while also being smooth. We will set up a top trim plane and drag it to the location where we want to trim off the body. Then use the trim body command to trim to the newly created plane, which we can select from the feature history. Now we can use offset surface to make a copy of the outer shell minus the top, and we will leave the offset at 0 for this one. Then we can use the copy paste feature, and we can select the original feature and paste it back in. The original surfaces are highlighted, and we can adjust the offset to 4 millimeters. We can turn off the subdivision body and see the inner and outer wall. Next, we will trim to the bottom offset plane where we want to start the transition to the mount unit. We move back to the full assembly to review our current model, and we can adjust the trim in the context of the assembly. So here we can make an adjustment to the value that controls the trim offset while we're working in the context of the assembly. We make our top level assembly the working part, and since we are modeling in the context of the assembly, we want to bring the inner and outer faces of this mount product into our assembly. We could make a subcomponent at this level or a lower level component, but in this case we will develop it at this upper level. In this case, the standard mount part has a product interface established, meaning a predetermined set of objects we can leverage into the assembly structure very easily. We select the component to reference, and then NX presents us with the predetermined interfaces we can link over. I select them and select OK. For the leg surfaces, we don't have any product interface established in this part yet because we have just built it, but we can directly wave link screen selected geometries into the assembly. When we hide the leg and the mounting parts, we see we are left with the geometry in the upper level part. Now we want to blend from the leg to the mounted surfaces. We access the through curves feature, which is called lofting in many other CAD packages. To create the through curve mesh, we first select the first section curve, and then the second section curve. And for the alignment of the surface, we have many methods to line up the two sections. Parameter maps from the parameters of one curve to the next, and we can illustrate this better by turning on Preserve Shape, where you can see exactly how the segments have been joined. Not a good option in this scenario. Arc length splits the two curves up into equal arc length segments and joins them. By points gives us point locations so that we can style the transition how we want. This option is great for wire EDM work, where one curve has corners and you want to control the precise transition of the wire cut. But in this case we use spine curve. We will use the normal plane of the curve to assign the sections between the two curves. We select the arc and we will get radial sections and a better result for this product. In O&P Designer's video, he used a transition like this one, but then he added rads and fillets. With NX, we can blend this all together in one single command. We can assign G1 tangency for the first section and select the face. We will do the same G1 tangency for the leg surfaces, which gives us a natural transition between the two sections. And we can see how it makes a smooth blend off of the mounting part. If we wanted the inner surface developed before the outer in the history, we can make the feature above our through curves the current feature, and we can build that inner one as if the outer one doesn't exist yet. Note that the arrows of the sections chosen are opposing. So once we build the surface, you will immediately see how the transition is not what we would like. So we flip the arrow direction, but there is still some internal twisting because the two locations aren't lined up. If you are sticking with the arc length alignment and want to realign the curves, you can select the section where you want this origin curve to start. Here I select this area as the origin curve so it lines up with the start curve below. This makes better transition. But in this case, let's stick with the spine curve alignment since it gives us a better result out of the box. And let's add our tangency constraints. We could cap off the top and bottom and radius it. But let's go back and focus on the parameters we set up at the beginning. We alter the coronal angle and watch the transition update. We alter the sagittal angle and watch the transition update as well. And note the abrupt and short transition will not be ideal for the volume that contains the leg. We can alter the sagittal offset and the in-toe and out-toe rotation. This assembly can now be saved off as a reusable template in our NX library, and we can take it a step further and use the product template author to create a dialog box that will simplify the designer's adjustments when there is an alteration requested. Because NX is a fully associative modeler, we can even set up a workflow where the designer can drop in a new leg scan and have all these changes cascade downwards to get an updated product. If you find any of these tools intriguing and think these methods could improve your workflow, please reach out to us at designfusion.com.